Hello guys, welcome back to my YouTube channel. For this video, I'll be focusing on doing the paper 3, okay, also known as the Amali test for the coming SPM 2022. Okay, so hope this video will help you guys in a better way lah. According to the tips and the hints that we all gotten from school, different school teacher, this and that, okay. So we can try to log on to this specific topic called the heat of neutralization. Okay, so for here, you can see the heat of neutralization. So from this heat of neutralization, okay, we just know that we have the apparatus and the materials specifically just for this experiment. Okay, but we are not sure. Okay, I cannot guarantee you lah. We cannot guarantee you what it's the exact question paper coming out, but they will be illegal. Okay, so from what we actually know, hydrochloric acid, like sodium hydroxide, okay, like your beaker with cloth, okay. So we try to actually create different questions to suit different probability for the coming exam on this Friday, okay. This Thursday. Yeah. So let me just try to discuss what are the possibilities we have for this coming Amali. We actually have prepared different type of questions and then with answers, and the PDF will be actually in the link in the description box later in the bottom. So in this case, let's start. Okay, so for your first thing we know about heat of neutralization, there are different possibilities. So when we do heat of neutralization, okay, from here the first thing, heat of neutralization, you confirm that you know it must be acid plus alkaline, correct? Because it's neutralization, correct? So definitely it will be alkaline, acid plus alkaline. So acid plus alkaline. Okay, but when you do your experiment, you first thing need to know a few things. Okay, you need to know like what is the hypothesis, what's the operational definition, what's the manipulated variables, what's the responding variables, what's the fixed variables and stuff. Correct. So you first actually have to find a problem from this possible acid plus alkaline experiment. So on our PDF right here, okay, we actually prepared like 4 different types of possibilities, okay, using acid plus alkaline, and then you can measure the heat. Okay, but of course when you do heat, okay, this thing here, heat, you must actually have a result. And what result would that be? That result will be your temperature change. Okay, temperature change. So what exactly is temperature change? As you all learn in physics and chemistry, temperature change is your theta. You remember your Q equals to MC theta? That will be your theta. So theta will be always your result, your thermometer reading. Then you use that theta to actually calculate your Q. You use your Q to actually link to your heat of neutralization, which is usually we know them as delta H. Okay, delta H equals to Q over number of mole, if you have learned all this formula before. So the different possibilities that we actually put inside here is, okay, my question 1. Okay, question 1, we try to change to different type of acid. Okay, so some of you might say, teacher, I see the list of apparatus and materials. There is no different type of acid. There's only one acid. Guys, as I said, this is our prediction. Okay, we don't want to actually miss out any different possibilities. Okay, if not, later if come out exam, then I never teach, you're gonna come to me. Okay, so I'll try to give you different type of questions, different type of possibilities, and then you all can just go through everything. And anyhow it's just one topic, right? Okay, it's just heat of neutralization, most likely lah. Okay, so the first one is where we actually have different type of acid. So different type of acid, where different type of acid means got what? Got strong and weak acid. Got strong and weak acid lah. So strong acid give you more heat, weak acid give you lesser heat. So then you have different heat of neutralization. Okay. Then number 2. Okay, so because for question number 2, we actually try to go the simplest way in this topic, where we only actually have to go and identify type of reaction. So what's the meaning of type of reaction? Means you try to just define and try to prove that heat of neutralization is actually exothermic reaction. So this one here will be the easiest among them, because there is no manipulated variables inside here. Means you just do the experiment, then you see heat release, you see temperature increase, then you prove that it's actually an exothermic reaction. Okay, so question number 2 is slightly easier than the rest because there is no manipulated. Okay, so that's why when there's no manipulated variables, the chances of it to come out is also lower lah. Okay, but as I said, different possibilities. Okay, number 3, we actually try to modify the presence of cloth or towel. Okay, if you all heard that before, your cloth of towel as insulator. So because we know that when we do experiment that relates to heat, we need to actually try to reduce heat loss to surrounding. We use polystyrene cup, we use like cover to reduce heat loss to surrounding. But from the list of apparatus and materials that we actually have, we are not provided with polystyrene cup. But instead, they give you towel, they give you cloth. So what we can do, okay, what we try to predict here is you need to do 2 different experiments. One is without the cloth, then you measure the temperature change. Then the other experiment is you put with cloth, okay, your beaker, you do experiment in beaker, you cover the beaker with cloth, and then you also measure temperature change. At the end of the day, you compare their heat of neutralization, you see whether got cloth or without cloth, whether is it actually affecting your heat of neutralization. So this is a third type of question that we try to analyze. And lastly, it's about what? It's about concentration of acid. Means this is the hardest one. Okay, you need to change concentration of acid. How to change? They wouldn't, from what I heard okay, from what I heard, the concentration of acid is not provided directly to you. Means they don't give you one concentrated acid, one dilute acid. But instead, they want you to prepare your own dilute acid from concentrated acid. So it means they will give you concentrated acid, but you yourself have to decide how much water to add to prepare a dilute acid. And the dilute acid concentration may be or may not be provided. Okay, it depends. So that's why these are the 4 different types of possibilities that I try to do for this video. Of course, the answers are all provided so you just go through it with my video. Then we'll try our best to score in the coming paper 3 Amali So let's move on all these questions here. Okay, so I will just by showing you questions and answers by discussion. Okay, so that this video is not gonna be that long. Okay, so from here, let's move on. Okay, so if you look into the first question, we call it the forecast question 1A. Okay, it's just a forecast, guys. Okay, let me remind yourself. It's just a forecast. It's not compulsory. It's not guaranteed. Okay, so for the first type of question, as I mentioned, we take acid plus alkaline. We're gonna mix together, and then we change into different type of acid. So let's say this is the steps provided, just in case it's unguided. Okay, our steps are provided. So you see, we're gonna measure and pour 50 cm3, 1.0 mole per dm3 of hydrochloric acid into a polystyrene cup. Then you're gonna say, teacher, I thought you said no polystyrene cup. Guys, it's a sample. So if you never say got polystyrene cup, then don't use polystyrene cup lah. You adjust the steps according to your question in the coming exam. Please don't copy this blindly into exam. This is not 100%. Okay, so you're gonna actually, if there is no polystyrene cup, you just pour into a beaker. And if it's a beaker, you have to mention what is the volume of the beaker. Okay, so let's say for here, we are still using polystyrene cup. If you're using beaker with cloth, then just write beaker with cloth like that. Okay, so of course, you see, we're gonna pour acid into polystyrene cup, pour your alkaline into another polystyrene cup, and then you're gonna actually measure and record the initial temperature. Once you have your initial temperature, you can mix your acid and alkaline carefully into the solution. You stir it by using your thermometer and record the highest temperature. So the keyword is record highest temperature. Don't say record final reading. Don't say record final temperature, because when you're dealing with heat, there is no final temperature. Final temperature means your chemical become hot, then become back to cold to room temperature. Then that one is final temperature. No, so you must be specific on this thing called highest temperature. Okay, then that will be your highest temperature to actually minus off your initial temperature to calculate your theta, the temperature change. Okay, so of course you're going to repeat the whole experiment with your hydrochloric acid swap to your ethanoic acid. You change it to ethanoic acid. So as I mentioned, this is the first type of question where you change your type of acid, okay, from strong to weak acid. Then you're supposed to get a result. Guys, these results is according to your result when you actually carry out the hands-on in school. Okay, don't copy paste this into your exam. Okay, as I mentioned, your result follow what you have when you actually do your experiment. So let's say for this experiment, we gotten like when we do strong acid, okay, initially it's 28 degrees Celsius, okay, then they actually reach a highest temperature of 34.5. So we hit 34.5 minus 28, you get 6.5. Then for weak acid and alkaline, you will get 5.0. Okay, so you realize that the theta, the temperature change, the temperature rise, is actually slightly lower in your weak acid. Okay, but strong acid give you higher temperature rise. Okay, so of course, once you got to this result, let's try to answer questions. So what questions we have? Okay, so what we are changing right here, we are changing the type of acid. So you have to bracket hydrochloric acid and ethanoic acid. If not, just write hydrochloric acid and ethanoic acid. Okay, be more specific. Type of acid only, yes, your teacher might give you wrong. Okay, so try to be more specific. If you're using type of acid, list the name of the type of acid you're using. Once you do use different type of acid, it will affect your different result, right? So you can say you can actually write highest temperature or heat of neutralization. Okay, because the temperature rise affects your Q, then your Q affects your heat of neutralization. So the ultimate goal of your responding variable, the ultimate result will be your heat of neutralization. So that's your responding variables. Then number 3, what you need to be fixed, what you need to be actually constant throughout the whole experiment, you need to actually fix your volume and concentration of your alkaline. So because you're changing type of acid, means your alkaline must be the constant variable, it must be fixed. So in this case, you must write volume and concentration. They come in a package. Don't just write volume, don't just write concentration. They must write both at the same time. So that's your fixed variable. Okay, then next moving on is a hypothesis. What's actually a hypothesis? In a general term, hypothesis is actually an early prediction, or we can call it a smart guess. Okay, you are trying to predict the future, try to predict the result. Okay, but of course in a logical way lah. Okay, not to say predict and then you predict something out from the experiment. So let's say from here we are using strong acid and weak acid, right? So who's supposed to give you more heat release? Who's supposed to have higher heat of neutralization? So according to our smart brain, okay, our smart chemistry brain, our smart guess is strong acid supposedly should give you faster reaction, should give you a more vigorous reaction. Maybe it should actually have a higher heat of neutralization. Then that will be your hypothesis. So as you can see, heat of neutralization between hydrochloric acid and sodium hydroxide, which is strong acid, is higher than the heat of neutralization between ethanoic acid and sodium hydroxide. You see the concept there? So from here we try to guess, we try to predict, maybe strong acid got higher heat of neutralization, and that gives you 2 marks. Okay, so that's your hypothesis for this experiment if you're using different type of acid. Then D will be your operational definition. This one commonly seen in all paper 3. So coming out also in the coming paper 3 also. Hopefully if this one come out, you all can manage to do. Okay, what is operational definition? Okay, in a general way, operational definition is you write what you observe, and what you actually do. Okay, what's the meaning of what you observe and what you do? What you observe is your result lah. Okay, so you see when you actually add your acid and alkaline, your thermometer reading should increase. That's your observation. That's what you see right now. The thermometer reading rise. So you see from here, thermometer reading increases. That's what you observe. But how you get thermometer reading increase is basically when you add your acid into alkaline kind of. So you see when sodium hydroxide is added to hydrochloric acid to form 1 mole of water. Okay, so this is basically to get you 2 marks in a one simple sentence, but students cannot do this all the time. Okay, so always remember what you observe and what you do is what you need to write in your operational definition to define what is the thing from here. How do you define heat of neutralization? You see after acid alkaline add, you see temperature increase. That's your operational definition. Okay, so hopefully this one got a better idea about operational definition. After that, if you are changing different type of acid, Okay, if you change to different type of acid, you might see this question like this. Okay, they'll say, explain the difference in temperature change between hydrochloric acid with sodium hydroxide and the reaction between ethanoic acid and sodium hydroxide. So technically, you're supposed to see more heat release, higher value for heat of neutralization for strong acid. You have a lower value for weak acid. So the thing is, they'll ask you why. Why strong acid got more heat release? Why weak acid got lesser heat release? Okay, so from what we know just now, hydrochloric acid is a strong acid which dissociates completely in water. So the word dissociate can be also known as ionize. Okay, I believe most of you guys learned ionize. So ionize. Okay, it ionizes completely in water. And then for ethanoic acid, it's a weak acid which ionizes partially in water. So because of this completely and partially, most of your ethanoic acid still exists as molecule. Guys, by the way, sorry for this blocking word here. Okay, just try to read through it. Try to write this by yourself, okay? So most of ethanoic acid still exists as molecule. Means they never ionize, okay? So what's the problem on this? If they never ionize, means during neutralization, a small amount of heat release, okay, during the formation of water, okay, means during halfway through the process, you release heat. So he's supposed to release a lot of heat, but because it's a weak acid, the heat release, they need to take back a bit. Okay, they need to take a little bit heat back so that you can see from here. Okay, is your heat release, small amount of heat release, is reabsorbed by ethanoic acid molecule to ionize the molecule completely. So if you compare this down, imagine this strong acid, because everyone is ionized, means the heat release can be completely released, go up. So when doing the whole neutralization, the heat just go up during strong acid. But for weak acid, the heat also is released, okay? But during the heat release, they realize, hey, got molecule, haven't fully ionized. So they will reabsorb a bit of heat that they just released, they'll take back a bit, okay? And use to ionize the molecule that didn't ionize in weak acid. That's why weak acid is supposed to give you a lower heat of neutralization. Okay. So usually, strong acid gives you negative 57 kilojoule per mole. Okay, but weak acid gives you negative 55 kilojoule per mole, just slightly lesser. You see, just 2 kilojoule per mole. Okay, and that 2 kilojoule per mole actually also should come out on, but they will take it back a bit to fully ionize the molecule that didn't ionize. Okay, so this will be the 3 marks question if they ask you to change into different type of acid from strong acid to weak acid, from weak acid to strong acid, like that. So this is a possible question if you change different acid. And next one will be the prediction. If you change your alkaline, because alkaline was a fixed variable just now in this experiment, right? What if they change to a different alkaline? So if you change from sodium hydroxide to potassium hydroxide, you realize that your heat of neutralization should be remain the same. Why? Because strong sodium hydroxide is considered a strong alkali. Then if you change to potassium hydroxide, it is still a strong alkali. So it means what? Strong alkali change to strong alkali, still ionized completely, no need to reabsorb any heat. Straight away, all the heat is released. You get the same heat of neutralization. Unless if you change from strong alkaline to weak alkaline, such as ammonia, then that one will be different. Okay, so the hint is strong to strong, no change. Strong to weak, got change. Okay, and why change? This is the answer. Okay, so when you move on with this, we are almost done with this. But of course, along the whole paper, question paper, they might ask you the common question in this chapter. And what are those common questions? Usually is your calculation and your chemical equation and energy and level diagram. Okay, so if you move on to the next page, you will see extra questions. These are paper 2 questions, just in case they ask you in paper 3. Because paper 3, they might have some limited marks, they have limited questions to ask. So if they got extra marks to actually spare, they will ask you maybe to write equation, to give you to do a calculation. Okay, so for writing chemical equation, hopefully you guys can just do this without my guidance. Okay, so I will not focus on chemical equation, just look at it. So hydrochloric acid plus sodium hydroxide, you get salt and water. Ethanoic acid plus sodium hydroxide, you still get salt and water. So these are just chemical equation. Okay, just for extra information, if your paper asks you to write ionic equation, guys, wait, my iPad lagging. Okay, ionic equation. Okay, what is the ionic equation for neutralization? Surprisingly, it's actually a fixed answer. Means no matter what acid you use, no matter what alkaline you use, it will be always the same ionic equation. And what is that? What is the definition for heat of neutralization? Remember that? Heat of neutralization is the heat released when 1 mole of acid react with 1 mole of alkaline to form 1 mole of water. Technically, every acid plus alkaline, you always form 1 mole of water, correct? Means your ionic equation, you only focus on H plus to form, of course, H plus with OH minus, which is acid plus alkaline, you form water. And this is fixed for all type of acid, all type of alkaline for ionic equation. This, remember guys, just in case if you ask about ionic equation, this will be the answer. Okay, then moving on, we have some calculation to do on. So what is the 3 steps calculation that we always do? Okay, the first one is always to start with number of mole calculation. But from here, because it's acid and alkaline, we always deal with MV over 1000. Okay, what is M? What's V? M stands for molarity, and V stands for volume. As you can see, since we have 2 different solutions, we have acid and alkaline. So we realize that I'm doing number of mole for acid, MV over 1000. According to question, guys, MV over 1000, the MV is a value given by the question. Don't put 1 and 50. Don't copy paste. Okay, must follow question. Then your alkaline, MV over 1000, still gonna get 0.05. So when you show that your 2 number of mole is the same number, you should relate them into a ratio sentence like this. Okay, according to equation from here, you see 1 acid, 1 alkaline, you form 1 salt and 1 water, right? You see from the equation, 1 HCl reacts with 1 mole of alkaline to produce 1 mole of water. But because right now the calculation we are having right now is 0.05, we relate to this actual number because 1 mole to 1 mole is the ideal case. Okay, it's the ratio from equation. But for this experiment that you're doing, it's only 0.05. Means from the equation, 0.05 mole of acid react with 0.05 mole of alkaline to produce 0.1 mole of H2O. So why do we need this? Because at the end of the day, later on, we're going to do a calculation that you need to use the number of mole of water. That's why we need to actually have this. Okay, can I answer this from here? Oh, guys, there's a mistake here. This is not 0.1. This is 0.05 because the ratio is 1 to 1 to 1 to 1. Okay, sorry guys, I didn't see that when I was doing this. It's a slight mistake here. So this will be 0.05. Okay, so first, once we actually had done with the number of mole, secondly, we can use the second formula. This is step 1. Step 2 will be Q equals to MC theta. Okay, theta provided by question. You see, I'm using 6.5. Okay. Then, do you see I got C? What is C? Given by question. Specific heat capacity. Always given, don't worry about that. But then what is M? M is 100 at here. It's not fixed, It's again depend on question. Because M, according to the question, they say density equals to what? What is density? I believe for those who are my students, you already know this concept. The reason why they give you density is not for you to do any what calculation, is for you to actually simplify your life, make your life easier. Why? Because if you actually try to go for the experiment, is there any mass to be used in MC theta? There's no mass, there's no solid here to be used in MC theta, but instead they have volume and volume. You see that? But can you take volume assumed as mass in our calculation? For here, can. Why? Because of that density equals to 1. Why density equals to 1? You can assume like that. Because if you all remember in physics, what is density formula? So density, guys, my iPad lagging again. Give me some time. Okay. So density is equals to mass over volume. Correct. So if they say density is equals to 1, you can bring your volume over the other side and multiply the 1. Your volume can be equals to mass. That's the concept of having a density here. So means in chemistry, your mass can just take volume. Just assume volume as mass because they will always give you density equals to 1. Okay, and why is it 100 for this case? Because you have 50 cm cube acid add into 50 cm3 alkali. So total volume is 100. So means your total M, total mass is 100. So from here, you MC theta, you press a calculator, you get your Q in how many joule. Once you have this, you can use a ratio format to relate what you actually have. Okay, so because you see from here, if we say that 0.05 mole, which is this experiment is 0.05 mole, releases 2,730 joule of heat energy. But when we talk about heat of neutralization, it's always try to relate to in terms of 1 mole, right? So means you convert the 0.05 mole to 1 mole. How do you do this? To convert 0.05 to 1 is you take 0.05 divide 0.05, only can become 1, right? So if here divide 0.05, your 2,730 also divide by 0.05 to actually convert into how many heat energy per mole. So in a simple way, some of you actually learned from me that we actually have a simpler way to do this. You can just take step 3, okay? Delta H equals to Q over number of mole. It's a straightforward shortcut, okay? So from here, you put inside. So your Q, just now we calculated from the question, is actually 2,730 over the number of moles, 0.05, you get a certain amount. Okay, so this way is using the ratio format. This way is just using formula format. Okay, either way works. But I would say, guys, textbook now they're showing ratio format. So it's better and it's safer to actually write in a ratio format. Okay, so formula is not wrong, just that some teachers don't accept this anymore. They prefer the method in in ratio. Okay, so 0.05 if you release 2,730, so 1 mole if you 54,600 joule of heat energy. So convert it into kilojoule, and the unit is kilojoule per mole. Why suddenly the per mole appear? Because now it's in terms of 1 mole, right? So the unit here is per mole. Q is not per mole. Why? Because Q is the heat released in this experiment, which is only 0.05 mole. How is it per mole? No, right? So for Q, the unit is always just joule. But for delta H, the unit is always per mole, kilojoule per mole, because they divided number of mole. Okay? And one more thing, do you see there's a negative sign? I believe most of you guys know what's the negative sign already. Negative sign stands for exothermic reaction. And how did you know it's exothermic reaction? From here, we know it's actually exothermic reaction because of what? Because of temperature rise. When temperature increase, it must be exothermic reaction. Okay, so on this case, this is your calculation, the 3 steps calculation, step 1, step 2, step 3. Hopefully you guys have a better idea about your calculation. And then moving on, we have to actually construct energy level diagram. And since most of the time is exothermic, you can just remember that it goes from high level to low level with your energy level on your y-axis. X-axis not necessary, x-axis not needed. Don't draw your x-axis, but you have to put in all the full equation, okay, of your whole reaction, and then into your energy level diagram. So this is the reactant. You see acid plus alkaline, you get salt and water. So the top part is always the reactant, the back part is always your product. And the graph, the level drop by how much is your delta H. So label up the delta H that you calculated, that will be your answer. Okay, but for here my calculation, guys, I didn't finish this because you're supposed to actually try it yourself on the different type of acid. Means this is only for hydrochloric acid. You're gonna do it for the ethanoic acid yourself, and you actually get a different value lah. Okay, so that will be your different delta H, and that will be for weak acid and strong alkaline. So that's it from here. Okay, they ask you to draw level diagram for each neutralization. So we actually label this. Okay, label this. Okay, this is for strong acid. This is for weak acid. Okay, but if you realize that the value that we put here is negative 57 joule, which is, I told you that if it's strong acid, strong alkaline, it's actually a fixed heat of neutralization. You get negative 57 kilojoule per mole. But you see, the value you get is only negative 54.6 kilojoule per mole. It's actually slightly lower than what you're supposed to get. You expected to get negative 57, but you only got 54.6. Why is that so? That's why our last question, see, theoretical value of heat of neutralization between strong acid and strong alkaline is negative 57 kilojoule per mole. Compare this value with the heat of neutralization you obtain from this experiment, and why is there a difference? From what we know, the theoretical value is negative 57, but your actual result you only got 54.6. But why is that so? Because we know there is no perfect experiment in your life. Okay, for all the theoretical value, they assume perfect condition. But in real life, how is that perfect? No. Why? Because you see, heat of neutralization obtained in the experiment is always lower. And why is it lower? Because you see, part of the heat is released to surrounding. Your heat can go up, can go down, can go different direction, and some of the heat is actually being absorbed by your apparatus, by a container. So if you are using a beaker, it absorbed by the beaker. If you're using a polystyrene cup, it absorbed by polystyrene cup. Okay. Then some of you might ask, sure, I thought polystyrene cup is there to actually prevent heat loss. Guys, if you remember, the word prevent heat loss is wrong. Why? Because polystyrene cup in real life, they can only reduce heat loss. They cannot totally prevent. It's only just reduce heat loss. That's why even if you use polystyrene cup, you still get less accurate value compared to your theoretical value. Theoretical value is perfect, 100% perfect condition. But in real life, there wouldn't be any perfect condition. But polystyrene cup is there to help you. That's why in your coming experiment, if they say beaker with cloth, that one is your insulator. So why we use polystyrene cup, why we use cloth? Because heat insulator can reduce heat loss of surrounding, so the heat from the cup don't come out, go into the thermometer directly. So this is a possible question that come out in your coming Amali test. Okay, so this is the first type of question. So moving on, of course, I will discuss only the difference between the different experiment. I wouldn't go through all this calculation again. These are all fixed question and might not be come out because it's paper 2 question mark. Okay, so the next experiment from here is, as I said, is just to identify whether is it exothermic or endothermic. So there will be no manipulated for this experiment, where you just pour the acid into a beaker, pour the alkaline into a beaker, measure initial temperature, measure highest temperature. Okay, then you get your result. Then you actually prove that the neutralization between hydrochloric acid and sodium hydroxide is exothermic reaction. That's a hypothesis. Because as I said, you are supposed to do a smart guess for hypothesis. So you try to guess that it's actually exothermic. And what we actually get for new operational definition, same as just now. Thermometer reading increase when your acid and alkaline react to form 1 mole of water. If they ask about operational definition for exothermic, just don't write form 1 mole of water. But the rest is the same. Thermometer reading increase when acid add into alkaline. Okay, and then this is what if they change into different weak acid? Then the explanation will be the same. So this one I'm not going to go through again. It's the same as just now. If they change from strong to weak acid, okay, based on temperature change, type of reaction is exothermic. What if you change from strong alkaline to another strong alkaline? Same heat of neutralization. So for this experiment, as I said, is less chance to come out, is less likely to come out because it's too easy. Okay, and there is no manipulated variable. You don't control, you don't actually change anything. So this experiment, we just put it just in case. Okay, but I would say low chance lah. Then moving on to the third type of questions. Okay, guys, extra equation. You just go through it. Okay, it's just the same calculation, equation, energy level diagram. Okay, then sometimes they ask you suggest precaution step to increase accuracy. You see, wrap the beaker with towel and rubber band, the one that you all have in your list. Okay, why? Because towel is or maybe your cloth is a good heat insulator that can reduce heat losses surrounding. These are the ways to actually increase your accuracy for your heat of neutralization. Then moving on, in the third question is where we change your manipulator is the cloth. You do one experiment without the cloth, you do one experiment with the cloth. Okay, but the rest is the same. You see, you still pour into a beaker, pour acid into a beaker, pour alkaline into another beaker. Okay, record initial temperature. Sorry guys, record initial temperature, and then pour them together, stir them. Okay, record highest temperature. Repeat everything with your beaker wrapped with towel and rubber band. Okay, so means right here, guys, you're manipulated. It's the presence of your towel wrapped around the beaker. Okay, so of course these are the results again, guys. Just a prediction, guys. Just a prediction, Not don't copy paste, Okay, so my manipulated is the presence of cloth wrapped on beaker, whether got cloth or not. Then that will affect your responding variable, which is your heat of neutralization in the ultimate way. And then for next one, fixed variable, still the same. Fix your volume on and concentration of your alkaline and hydrochloric acid. Everything fixed, okay, everything fixed. Just now, right now, your only thing that you're changing is the cloth that is wrapped around the beaker. Okay. And then what is a smart gas? Got cloth means got insulator, ma. Got insulator means that it's supposed to have lesser heat loss to surrounding. Means you're supposed to get a higher heat of neutralization. So see, the one with cloth wrap beaker is supposed to be higher heat of neutralization compared to the one without the cloth wrapping around. Okay, so that's the hypothesis. That's a smart gas. The two same definition again, the operation definition. Not going to go through this. Same like just now. And then again, if you change it to weak acid, same. We try to put in here because these are the common questions inside this topic here. Okay, so these are not going to go through it. Okay, extra questions. Okay, same calculation, same equation. Your energy level diagram. Okay, your explanation on why your cloth can help you to get better result is because cloth or maybe your towel is a good heat insulator that can reduce heat loss to surrounding. Okay, so definitely the only changes is the manipulated variables and of course your results. Okay, so of course when the result is affected, you will affect your calculation. Just the value affected, like guys, the concept, the method is the same. Okay, so you see, still MVO 1000, still ratio, still MC theta, still your delta H, okay, everything. So you see, this one is normal beaker, this one is wrapped with cloth. Just try to do the both experiment, you realize that the calculation come out. The one with cloth can give you higher heat of neutralization. The one no cloth give you lower heat of neutralization. So that's the concept from here. Okay. So then, in this case here, this is actually the three different type of question that we actually have, which is very similar. We just changed into different manipulated variables. And the last type of question is the hardest part. Why? Because when you want to change concentration, that's very hard. Okay. Give me one moment, guys. Let me just move on to concentration of acid. Let's move on. Okay, in forecast question 1D, which is our last type of possibilities, is where you change into different concentration. As see from here, you have set 1, set 2, and set 3, where you actually use only one type of acid and the same alkaline, okay? But then do you realize that you actually reduce the volume of acid, but you increase the volume of water? Means you are using water to dilute your acid, become less concentrated, become dilute acid. Okay. So from here, you see, okay, on this case here, using the formula given, okay, you're gonna calculate. You have a different calculation. Why? Why do you have a different calculation? Because you are doing a method here called dilution method. And what is dilution? For most of you guys that you don't remember, dilution formula is actually M1V1 equals to M2V2. What exactly is M1V1 equals to M2V2? Sounds very familiar to physics, right? To physics momentum formula kind of. No, actually chemistry also got. Why say so? Because okay, let's just discuss a little bit on here. M1V1 equals to M2V2. This one is actually dilution formula. Where what is dilution formula? What is dilution? You have a concentrated Milo. You have a very sweet Milo. How are you supposed to dilute a very sweet Milo? Add water kind of. So M1V1 equals to M2V2 is before add water. Okay, then M2V2 is after add water. Means before and after you add the water. So how you do, let's say from here, okay, calculate the concentration of hydrochloric acid in the table 1. Let's say if they give you all this value, they give you 25 cm of acid and 25 cm of water, okay? Then what is the concentration? Do you see this is actually our answer. Okay, if you do the question in the front, you're supposed to see this is empty. Okay, so you realize that originally your acid is 1.0 mole per dm cube. This is the acid they give you by your school teacher. Okay, but they ask you to prepare a different concentration. Let's say they want you to actually don't use 50 cm cube of acid anymore. They ask you to use 25 cm cube of acid and 25 cm cube of water. Then mixed together, you only get 0.5 as your concentration. Why suddenly becomes 0.5? According to the formula, you see. This is M1V1, the initial molarity, the initial volume, which is the 25 cm cube of acid, right? Then, do you see V2 is 50? Why V2 50?
because of the acid after adding water. Acid 25, add water also 25. So 25 together is 50. So when your volume V2 is 50, then you do your maths, okay? You multiply this, you bring this over, you divide, you get your M2 is equals to 0.5 mole per dm cube. Okay? But if you use more water and lesser acid, usually in set 3, more water, lesser acid. Acid only 5.0, water got 45 cm cube. You see that? So more water, less acid. Let's see what's the concentration. See, if I do put in my formula, I say less acid, but still 50 cm cube here. Why? Because at the end of the day, your acid is 5, your water is 45. So total is still 50. Okay? You just use less acid with more water. Okay, when you use less acid with more water, you see your concentration becomes 0.1 mole per dm cube. So you see from here in the beginning, it goes from 1.0 to 0.5 to 0.1. You are actually decreasing your concentration of your acid. So now, your experiment, you get different acid, right? You have different concentration of acid. Add it into your alkaline. See the heat release, see the temperature rise. So of course, our result still gonna have something like this. You can see, right? Different set, different results. You can see, right? The set 1, you get 5.0 as a temperature rise. Set 2, you get 2.5 as a temperature rise. Set 3, you get 0.5 as your temperature rise. Okay, so from here, do you realize that when you actually use a dilute acid, your temperature change, your temperature rise is actually lesser and lesser? From here, we know that your theta is different. So when theta is different, your Q is different. Okay, so moving on, you see what is our manipulator for this experiment? We change the concentration of acid. Okay, and this concentration, will it affect your responding variable? So our result here, you can write heat of neutralization, you can write the temperature change, temperature rise, and of course still fix your alkaline volume and concentration. Okay, but what is a smart guess here? The smart guess here, you say, teacher, can I write the higher the concentration, the higher the heat of neutralization? One concept is a bit different here, guys. It's a bit different. It's actually not a bit different. It's totally different. See, our smart guess is the higher concentration give you higher temperature change. But your heat of neutralization remain the same. Why is that so? Let me just show you some calculations so you guys can have a better idea about it. Yeah, imagine this. Okay, I think there's a calculation at the back. Let me see. Okay, okay, you see the calculation at the back, by having different theta, okay, different theta, you see, set 1, set 2 have different theta, right? Different temperature change, right? You have different Q, correct? You have different Q, but because your concentration also affects your number of mole, you see, set 1 number of mole is 0.05, set 2 number of mole is 0.025. So what's the meaning of this? Means by changing concentration, okay, what's all the 3 formulas we learned just now? We have number of mole equals to mv over 1000. Okay, we have q over mc theta. We have delta h equals to q over number of mole. So by using your maths logic, if concentration decrease, your number of mole also decrease. But you realize your theta also decrease. Because when you use lesser concentration, our result is theta decrease. If theta decrease, Q also decrease. And what's the point of this? You realize when your Q decrease, your number of mole decrease at the same time, your delta H supposed to be constant. Using maths logic, if the right-hand side decrease at the same time, your constant, your left-hand side delta H shouldn't have any changes. You see, why? Because you see, even if you get lesser heat, you also have lesser number of mole. You see, 2100 divided by 0.05, you get 42 kilojoule per mole. Set 2, you take 1050 divide 0.025, you still get 42 kilojoule per mole. Do you see your heat of neutralization is the same? Because when you change concentration, Q and number of mole will also change. Then your delta H will be fixed. Your heat of neutralization will be fixed. So that's why this experiment will be slightly weird. Okay, it will be actually weird because you see, teacher, I thought this topic is about heat of neutralization. I thought we are supposed to change the heat of neutralization, but no, guys. The only way to change heat of neutralization is to change your type of acid. The one that we did in the first question, strong and weak acid. That's the only one will change your heat of neutralization. Of course, with the insulator, that one also change lah. But changing concentration, our hypothesis again, it will change your temperature change. Okay, higher concentration, higher temperature change, but heat of neutralization remain the same. Okay, so this is a different hypothesis compared to the 3 questions that we have just now in the front. Okay, this one is slightly different and it's slightly harder. Okay, but of course the rest is the same. Operational definition, same. Okay, and then of course if they change it to weak acid, same. Okay, calculation slightly different value, but then you still do the same method again. Number of mole, Q equals epsilon theta, delta H equals to Q over number of mole. Everything is the same. Okay, so from here they ask you, sometimes they ask you, which experiment has higher heat of neutralization? And you see that set 1, set 3, they're all the same heat of neutralization, because heat of neutralization is heat released when 1 mole of water is formed. Because when you calculate in terms of 1 mole, everyone is the same. Okay, the reason why they have different Q, you see, set 1 Q is 2100, set 2 is Q 1050, because lesser concentration means lesser water molecule form, then get lesser heat. But if you compare to in terms of per mole of water, they are the same. Okay, so this experiment is slightly harder because they change concentration, and concentration only change your Q. It doesn't change your delta H. Okay, it only change your number of mole, only change your Q, but it doesn't affect your delta H. So your experiment at here, okay, is actually the same heat of neutralization, because heat released in terms of 1 mole is constant, is the same. Okay, the rest of the precaution step, the rest of the accuracy improvement is the same lah. Okay, try to wrap the cloth around the beaker, try to put a cover on top of it, this and that. Okay, so actual question is almost the same, but the concept for here is different manipulated variables. Okay, so guys, in general, we have 4 different types of heat of neutralization here. First type is to change different type of acid, strong or weak acid. Second type is to just to find out whether is it exothermic or endothermic. That one very easy, which is the lowest chance. Type 3 will be having cloth or no cloth as your heat insulator. Then you can reduce heat loss to surrounding. The type 4 is you change your concentration of acid, which is the hardest one. Okay, change your concentration of acid. Be careful, guys. So of course, all this calculation, I have to go through it again. Okay, any question? Leave your comment in below the video. I'll try to answer you guys through the comment section. Okay, don't forget to go through all the procedure, because there might be a chance of having unguided for chemistry. Okay, let's not risk it. You try to, because it's just one topic. What's so hard about memorizing the procedure, right? Okay, so guys, for this video, I hope this video can help you guys better in the coming Amali test for this coming Thursday. Okay, so that's all for this video. I will wait for the good news after the Amali test. Okay, I'll see you guys in my next video. Okay, thank you, and see you next video. Okay, bye guys.